Assalamualaikum warahmatullahi wabarakatuh. My name is Coulomb'S. I am going to explain to you about first experiment, Coulomb's law. The objective of the experiment are to study Coulomb's law experimentally. Second is to study the parameter that affect the electric force and to find experimentally the electric constant K. Here is the step or procedure carried to find the relationship between the force and distance squared. The graph and table obtained show that the magnitude inversely proportional to the square of the distance between them. The value of Q1 and Q2 were fixed at 2 microcoulomb and 4 microcoulomb, and the distance between two charges will change. As the force of attraction and repulsion between 2 points decrease, separation distance will increase. From the graph, we can conclude that as the distance between two charges decreases, the electrical force will increase. The percentage error for part 1 was calculated, showing that the percentage error was 0%. Since it was done in online simulation, the measurement was precise because no measurement errors occurred. Here is the step or procedure for part 2 to find the electric force between two objects as the object charge was changed. For the second part, the distance was kept the same and the force for the charge different volumes was measured. The result obtained showed that the magnitude is directly proportional to the product of charge. The Q1 and distance value was fit at 5 microcoulomb and 6 cm. Also, Q2 was set at 10 microcoulomb. The hypothesis was proven when Q2 decreased, the electrical force also decreased due to the size of the force proportional to each charge volume. To conclude, the parameter affect the electrical force. The percentage error even 0% because no charge leakage occurred throughout the experiment. In conclusion, the objective was achieved as Coulomb's law was proven. Based on graph 1 part 1, the electrostatic force was inversely proportional to the distance. For graph 2, the electrostatic force was directly proportional to the 1 over distance squared due to the force of attraction or repulsion between the objects was decreasing as the separation distance increased. The graph on part 2 shows that electric force is directly proportional to the charge of the Q2 due to the size of the force proportional to its charge volume. Lastly, the percentage error for both graphs is 0%, which is accurate to the volume of electric constant K.
Assalamualaikum, my name is Noha Nazarudin and I'm going to explain about experiment 2, capacitance. Without further ado, let's take a look at the objective in this experiment. The first one is to study the capacitance varies with the separation between the plates, and to study the capacitance varies with the area of the plate, to study the dielectric effect on the stored charge, energy and voltage between the plates of the capacitor. Next, let's take a look at the procedure of part 1, which is capacitance. This procedure was conducted on simulation with the link provided. As you can see, diagram below me shows that the material and apparatus were set up according to a procedure that was stated. We used paper and all the material above on the simulation in order to study about the capacitance varies with the separation between the plates and the capacitance varies with the area of the plates. Now let's take a look at the result we obtained in the experiment part 1. Let's discuss about the analysis of the data. For the first part of the experiment, two graphs were obtained, and I'm going to mention about the first one, which is the graph of capacitance against the separation between the plates. The graph that we obtained is capacitance is directly proportional to the separation between the plates. For separation between the plates, it shows that when the distance is 0.1 mm, then the result was 0.31 times 10 to the power of negative 12 F, and while the distance is changed to 0.1 mm, the result was 0.34 times 10 to the power of negative 12. This proves that when the distance is 1 over d increased, the capacitance C will increase. Now moving on to the second graph, which is the graph of the capacitance against the plate's area, and as it's the same, it's directly proportional. For the area of the plates, when it is 100 mm squared, the capacitance was 0.31 times 10 to the power of negative 12F. And the results show that the continuous increment when both variables were increased. Hence, it proves that the area of the plate is directly proportional to the value of capacitance. Next, let's take a look at the procedure part 2, which is effect of the dielectric on the capacitor. To differ from the part 1, which part 1 we have to observe and the values were recorded. However, in part 2, there's only observation were recorded. Firstly, the values of the plate that originally on the part 1 was reverted and the dielectric was removed from the capacitor. For a better understanding, let's take a look at the materials and apparatus on how it was set up on the simulation below. Experiment 2, the effect of the dielectric on capacitor. For this part, two tables were obtained to see the different result of the presence of dielectric on capacitor. The capacitance, charge, voltage between plates and energy stored by capacitor were changes that we observe at the end of the experiment. Presence of dielectric in battery, it shows an increasing for every subject. However, for absence of dielectric and battery, results were almost different as only the capacitance were same throughout both experiments. Nevertheless, the charge value remains the same despite it shows an increase in presence of dielectric. However, voltage between plates and energy stored by the capacitor, it was decreased while it was an increase for another factor. From the table, it is proven that the presence of dielectric gives different effects. To conclude this experiment, on the first part of the experiment, which is the experiment for capacitance, at the end of the experiment, we could take that energy was conserved as the capacity to store electric charge depends on the area of the plates provided. Therefore, based on the graph that we obtained, calculation and percentage of error and also experimental value of K were calculated. Therefore, percentage error for both graph and at the end of the experiment obtained as 0%. For experiment part 2, the experiment obeyed the law of conservation of charge based on the results obtained. This can be proven based on the simulation. When the battery was connected, the dielectric that were placed in between the plates, making the charge capacitance increases, but no changes with the voltage as it is remained constant. However, the other way around, when the battery is connected, only charge is constant unlike capacitance. The reading for capacitance is increasing.
Hey, my name is Shazwani and I'm going to enlighten you on experiment 3 direct current circuit. The objective of this experiment are to measure the current and voltage for a simple direct current circuit. Next is to study series connection of resistors. Lastly is to study parallel connection of resistors. This is the procedure for part 1. The procedure was carried out to measure the current and voltage for a simple direct current circuit using an online simulation. The result and graph was done. Based on the result obtained, we gathered that the measurement of the current and voltage in simple DC circuit, the result and graph had proven that Ohm's law, which is the intensity of current in a circuit, is directly proportional to the voltage and inversely proportional to the resistance of the circuit itself. As the graph has shown, voltage are directly proportional to the current. For example, in trial 1, the voltage was 9 volts and the current was 0.9 ampere, while in trial 2, 20 volts voltage result in 2 ampere. This shows as the voltage increased, the current increased as well, while the resistance was kept constant in a series circuit. This is the procedure for part 2. The procedure was carried out using an online simulation to study series connection of resistors. Based on the result obtained, firstly in table 2 shows that the value of V1 and V2 individually, 48 volts and 72 volts, are similar to the total voltage 130 volts. This is because the Ohm's law stated that the current is the same in each series circuit. Secondly, the value of current before R1, between R1 and R2, and after R2 are the same. This is because a series circuit was used. Therefore, the equivalent resistance of the circuit is the sum of the individual resistance as there was only one path for the current to flow in a series circuit. Thirdly, the result has proven the Ohm's law formula, which is V equal to IR. Therefore, the sum of current and resistance are equivalent to the voltage. Moreover, for non-ohmic conductors, the graph of voltage against current was not a straight line.
Hello, my name is Nur Ainasa. Now I will continue to explain about the third part from this experiment, and this is the procedure for part 3. The procedure was carried out to study parallel connection of resistors. Based on the result gained on R1 and R2, the voltage for both were 120 volt by the voltmeter. The result is still valued due to the reason that the amount of voltage across the resistor is not affected by the amount of resistance on the resistor. So the total of the voltage was received as a parallel circuit connected with the wires that was assumed to have negligible resistance. Next, the current on R1 was higher compared to R2. The current became decreasing because when more resistors are added in parallel to a circuit, the equivalent resistance of the circuit decreases and the total current of the circuit increases. The results different because parallel circuit have more pathways for current to flow, so the total current was the sum of the currents flowing, I1 plus I2. Therefore, in parallel circuit, the total resistance is always less than any of branch resistance. The more parallel resistance added to circuit, the total of resistance become more decreases. The condition obeyed the Ohm's law as it states that the current was higher when the resistance was lower. In conclusion, the objective of this experiment was proven. First, the result achieved from part 1 proved the definition of the Ohm's law, which states that the current through a conductor between 2 points is directly proportional to the voltage across the points. From graph 1.0 in part 1, as the current increased, the voltage also increased. The hypothesis is accepted as it shows that the current is directly proportional to the value of voltage. Next, based on the results in part 2, we can conclude that when the resistance of a resistor increases, the voltage across the resistor will also increase. It proves that the amount of voltage across the resistor is affected by the amount of resistance on a resistor. For the current readings, it shows that the value is constant throughout the experiment. This happens because a series circuit was used and it flows the same value of current in one way of the circuit. For part 3, results from R1 and R2 indicate the voltage was both at 120 volts. The result has the exact value due to the reason that the amount of voltage across the resistor is not affected by the amount of resistance on resistor, hence proving the more parallel resistance added to the circuit, the less total resistance. This hypothesis proves Ohm's law, where the lower the resistance, the higher the current.
Bismillahirrahmanirrahim. My name is Ahmad Hussein B. Hamza and I will explain about experiment for magnetism. The objective of the experiment is to investigate the compass and electromagnetic pole, to study the relationship between number of loop and the field strength, and lastly to study the relationship between voltage and the field strength. This is the procedure for the experiment. The procedure was carried in online simulation to investigate how compass and electromagnetic force works, the relationship between the number of loop and the field strength, and the relationship between voltage and the field strength. Here are the results obtained at the end of the experiment. Based on the table, number of loops against field strength shows that the amount of the field strength increases as the number of loops increases. Meanwhile, for field strength against the voltage, results that we obtained were as the voltage increases, the electrical field strength also increases. Moving on to discussion for the experiment, at the early part of procedure, a compass was moved around the bar magnet. This is to determine the position of south and north pole. The magnet makes the red compass needle points towards only the south pole, even when the polarity is flipped. This means that the red part of the needle is the south pole. One end of every bar magnet will still try to point to the north if it is voluntarily suspended. Last but not least, does the field strength increase or decrease as you move the meter closer to the electromagnet? The field strength increases when the meter moves closer to the electromagnet, as it shows on the data of the results that the amount of electric field increases as the number of loops in the electromagnet increases. This is because it obeys the same inverse square law as the magnet. The intensity of the magnetic field increases as the distance between the meter and the sources of magnetic field decreases. As for the conclusion, the objective of the experiment was to investigate on how compass and electromagnetic force works, the relationship between number of loop and the field strength, and the relationship between voltage and the field strength was achieved. As we all know, a compass is a device in which helps to tell the direction of south and north pole. In the experiment, a compass was placed around a bar magnet and result shows that the red compass needle only points to the south pole, even after the polarity of the magnet was changed. Hence, we could conclude that the red compass needle indicates the south and the other end of the needle represent the north. Next, the relationship between number of loop and its field strength. Based on the result obtained, it shows that when the number of loop increases from 1 to 4, the reading of field strength also increases. The magnetic field strength can be increased or reduced by increasing the number of loops in the coil. Thus, the more loops have been added, the greater the field will become. Last but not least, the experiment in which studies the relationship between the voltage and the field strength. Result from table 2 shows that when voltage increases from 0 to 10, the field strength also increases respectively. This is simply because the voltage induces the movement of current. This experiment is quite similar to Ohm's law experiment, where the current flows through the resistor. But in this experiment, the electromagnet was equal to the voltage flowing through it. From that, we can assume that if the voltage is high, then the field strength in the electromagnet is also expected to be high.